Okay, so this is a nice looking question. We want to evaluate this one here. Let's see, inverse tan of 1 on root 2 is going to be some type of angle. So we actually have two lots of an angle. This is actually a double angle result. But we don't need to worry about that just yet. Let's just start this question off the way we always do. Pick your favorite pronumeral for an angle. Let's use alpha on this one. We're going to let alpha equal this inverse tan 1 on root 2. Now, if alpha is equal to that, that's going to imply that tan alpha is equal to 1 on root 2. We're dealing with first quadrant here, right? Because tan is positive. Again, third quadrant also normally, but we are dealing with inverse trig, right? So it's going to be either first or fourth quadrant. So we've got first quadrant. We know what sort of a triangle we're going to end up with here. So get out your Pythagoras' theorem. Tan is opposite over adjacent. Pythagoras' theorem is going to give you the square root of 3 there for the hypotenuse. So from here, we can work out we know what tan alpha is. Sine alpha is going to be opposite over hypotenuse. And cos alpha is going to be adjacent over hypotenuse. The reason I've done that is because when we look at what we're trying to evaluate, it's sine two lots of inverse tan 1 on root 2. But check it out, inverse tan 1 on root 2 is what we called alpha. We're trying to evaluate sine 2 alpha. And we know from double angle results, the double angle result for sine would be 2 outside of sine alpha, cos alpha, and check it out. We've already worked out what sine alpha is. It's 1 on root 3. And the cos alpha is a root 2 on root 3. And there you go, pretty cool question. So you're not with 2 root 2 all over 3 in the end. And that's the value of that question there. All right, hopefully that helps, and good luck with your maths. All right, see you next time.